What's up guys? In this video I'll go through the design of a Tesla Model S I created in SolidWorks. It took me quite a long time to model this, probably about 50 hours, but a lot of that I was learning as I went along. So in this relatively short video I'll go over some of the things I learned while doing this and some of the general tips in modeling a car or a Tesla. So I'll just show you some views of the model. So I was quite happy with how this turned out. There were some small issues here and there, and I'll run you through some of the issues I found along the way. I'll just change the view quickly. So to model this, there was a lot of surfacing involved. So if you're not familiar with surfacing, it's alright because this video will just be a general overview. But for those interested, I'll quickly show you how to create a surface in SolidWorks. It's actually not that hard. So I'll create a new part. So with surfacing, you want to go to 3D Sketch. And essentially you want to draw 4 bounding lines. And we use the spline to draw our lines for a surface. So we're drawing the bounding edge. So a quick tip, if you see the XY symbol, that means that you're drawing on the XY plane. If I press the tab button on my keyboard, it will change the plane. And you can zoom around, rotate around to get a better view. You want to draw 4 separate splines for your edges, and they can have a different number of points. So something like that. And if I want, I can right click or just click on the spline and edit it with the spline handles. So when you're creating a model that has intricate curves, you'll draw your splines and then use different views to update the curvature to try get it precisely what to match what your intent is. So now I'll go into surfaces and I'll do a boundary surface. So with the boundary surface, I'm going to right click the box and go to Selection Manager and then make sure I'm on Select Group. I'm going to select one edge, right click to OK that, go back to Selection Manager, and I'm going to select the opposite edge. Now go down into the purple box and do the same. And there we have a surface. So generally speaking in SolidWorks, when you're creating a surface, you want to have 4 bounding edges. The underlying mathematics prefers that, but there are some ways around that, and I'll go into more detail in the video. So jumping straight into this, I'll open up the main body. And as you can see, there are quite a lot of features in this model. So I'm just going to quickly go through. It would take far too long to go over every step. The first step to start with for this specific model is to get some blueprints. So I just did a Google search of some Tesla Model S blueprints and I cropped these and imported them into SolidWorks. It's not too difficult to do that. I believe you go to Tools, Sketch Tools, and then Sketch Picture once you're actually in a sketch, and it'll allow you to import an image in. So I've imported a side view, front view and rear view and top view. And my method is to draw curves which match certain areas on the blueprints. It's important that when you import your blueprints, you scale them all correctly. So there is an option to set the essentially the width of the image, and you want to make sure that all your views are the same scale. So when you're switching between views to make your model, that you're working with the same dimensions. So starting with the first surface, I'll jump into the sketch, and I created some splines here. As we can see, it's a 4-sided area in 3-dimensional space. So I'll turn off real view graphics, and I might just exit this to turn off perspective view. So this top spline, it's following the curvature of the top front bonnet of the car, and the bottom spline is following, similar edge on the bottom. And then this spline is following a section near the wheel. And what I've done is, on purpose, I'm only modeling half of the car. So all my surfaces initially are going to be on this side plane, because I know this is a symmetrical model. So once I've finished half, I can just mirror and I'll create the full model. So what you want to do is minimize the total number of surfaces in your body. So obviously we can't create the whole car with a single surface, it's just not possible. But we don't want to have, thousands of surfaces. We want to try to keep it as efficient as possible. And also when we're creating our splines, we want to have the minimum number of inflection points. So this spline, for example, just has the 2 points at its ends, and then I've adjusted the spline handles accordingly. And when you create your surface, that just results in a neater, crisper surface with less discontinuities. So once I'd done that 3D sketch of those splines, I just went into boundary surface. And boundary surface is generally the most versatile surfacing tool. I do use pretty much all of the other surfacing tools, so I'll quickly go over them as the video progresses. But in boundary surface, you have some options, for example, direction vector or normal to profile, which I'll also get to in a second. So after I'd made that first main surface, I proceeded to make a secondary surface. And this surface was following a front section of the car. Now, ideally, you'd like to have a surface which does the whole bonnet, but the Tesla Model S specifically, let me just pull up a photo. It's also a good idea to have some photos of what you're trying to model. So looking at this photo, on the Model S's front hood, there is this kind of sharp edge running along like where my mouse cursor is, and also another one here. So they would be good edges for the surfaces we're creating in SolidWorks, because if you've got a sharp edge or a kink in a surface, you want to make that your boundary, because it will be hard to capture that detail if it were in the center of a surface you're modeling. So a lot of this stuff just comes with experience, knowing how to partition the surfaces of the body you're trying to make, which is really, that's the difficult part. Creating a surface isn't difficult, but knowing how to, the kind of stages to take to get to a final model is just what comes with experience. So for the sketch of that surface, I did part of the line on the existing edge of the first surface, and I did a couple more splines which go along those kinks that I was mentioning. So when I'm drawing these splines, I'm constantly switching between different views to try to get it to match as close as possible. And you're never going to get things to match 100% to the blueprint, so sometimes you just got to know when to call it and have some intuition and just decide what looks good and what's reasonable. So I also found that trying to get the exact curvature that I was aiming for, I had to add in some additional guide curves, which are these curves along here. So if I just go into that second boundary surface, in the purple group, it doesn't really matter what you put in the blue or purple groups, as long as they're essentially running in different directions. So this purple group, I did these opposing edges. And then in the blue group, instead of just having two kind of boundary edges, I had some additional ones in the center. And I can see, for example, that I must have decided not to use this center one because it wasn't giving me the right results. So a good way to evaluate your design as you're going along is to use zebra stripes. So these somewhat represent the way light will reflect off the surface if it were actually fabricated, and also curvature, which gives an idea of the the rate of change of the surface. So black is relatively flat, and green to red has a sharper curvature change. So that initial surface I did there was a large one, because if we look at the actual Tesla Model S, there are these cutouts, which are maybe the front grille or the front lights. It would be kind of difficult and inefficient to just sort of model all these little surface sections in between these areas. A better way is to just cut out the regions you don't need once you've done the model. So to do that, I use the split line feature, where I essentially create a sketch. Now this is actually a two-dimensional sketch, which was just on this plane here, my front plane. And the split line tool, which I believe is under features and curves, will project this 2D sketch you just did onto a 3D surface you have. And then so it will look something like that. And then once I have that, I can use the delete face tool, which is in the surfacing ribbon, to delete away the sections I don't want. So that's essentially the bread and butter, if you will, of the modeling process. So I'll just skip through some similar sections. Here I created another surface. Most of these are boundary surfaces. And again, I'm following the kind of guide curves on the blueprints. You can see it slowly starting to build up. There I did another split line feature to cut away the section for the front light. Another boundary surface, another split line in this section down here, and a delete face. So the reason I did that step just there was because I was trying to optimize this region where the front door starts. And I was finding that if I just drew a 3D curve directly following that, when I went and used the zebra stripes and curvature analysis, I wasn't really getting the desired shape of the surface that I just made. So sometimes it's I've found it's better if you create a larger surface and then use the split line to trim back to just keep the region you want. And again, that's an experience thing. And essentially there's no one right way to model something like a Tesla Model S in SolidWorks. By no means have I done it the perfect way. I was learning as I did this. So it's just something you play around with and get a feel for. And to be honest, SolidWorks really isn't designed for something this complex, and I'll talk about that a bit towards the end. So there I created another boundary surface which runs the length of the car. So you want to try keep these surfaces as large as possible, but if you try keep them too large, like if I tried to do the whole side region of the car in one surface, I'm not going to capture the design intent. I'm not going to capture like all the details of the way the curves of the car change. So the reason I decided to end it here just before this second door handle was because I can see a kink running along the side of the car which ends just about in that region just before the second door handle, and then a bit above that is another kink which starts. So if there are kinks in surfaces, as a general rule, they're good kind of boundary sections to model your individual surfaces off. Moving along, I believe I just added some more surfaces to the front there. Yep, I did another split line cutout section for the front. Did some more boundary surfaces. So I'll just jump forward quite a bit here, slowly building up the profile of the car as I go along, one surface at a time. Okay, now this region of the car, I remember I had quite a bit of difficulty. I got the model to work, but if I turn on the curvature, we can see that the surfaces don't smoothly transition into one another. It's not too bad, but for example, this region here, how we can see it's green and it continues to be green, that's ideal. That's what you want, because you don't want there to be a noticeable edge between the boundary of your surfaces. But here, for example, we can see it's kind of black on the left here. In the middle, it's sort of following it, but then on the right, it sort of just jumps from black to blue. So that's not ideal. And in hindsight, I probably could have partitioned this region a bit better. For example, this surface here was probably too small. But yeah, I was having some difficulty modeling that specific transition section in the car. So this was the best I could do at the time. Now, one negative thing about surfacing in SolidWorks is that it's very difficult for me to come back and change this. It's pretty much actually impossible. If I decided, hey, I don't want this to be, these surfaces to all be so small, I just want to do that whole section in one, I would have to come back and delete multiple surfaces, put a new one in, make sure it's mating correctly with all my other surfaces in the car. And because features after this region are so dependent on these surfaces, the whole model is essentially going to break, and the amount of effort I would have to put into rebuilding it would, it would almost be impossible to do. If I wanted to drastically change this, there's just no easy way that it can be done that I know of. So another program, for example, CAD, which is actually made by the same company, Dassault Systems, it does have the functionality where you can go back and even push and pull on points to quickly update surfaces. Whereas in SolidWorks, the continuity between all these surfaces, for example, if I open up this one, here I've chosen tangency to face as the option between these two surfaces. So what that means is at the boundary, each section is going to be tangent to the previous surface. I could also do none, which just means, the surface can be free, so there could be a visible kink. Or I could do curvature to face, which not only keeps the surface tangent, but the rate of change of the curve at any point on the surface is staying the same. And I could do direction vector, which is if I wanted to specify a specific way for the surface to project in. So these are known as G1, G2, and G3 surface continuity. I'll just double check that. G1, G2 surface continuity. Okay, sorry, G0, G1, G2. I'm pretty sure G2 and G3 are essentially the same thing. So G0, as we can see on the left, in SolidWorks that would just be, a point contact. You would just select none, and there'd be a visible kink or a visible edge where the surfaces meet. G1 is tangent, which is pretty good, but you would still be able to see a discrepancy where the surfaces meet when light is reflecting off it or when it's bouncing off it. So really for automobiles or aircrafts or any kind of aesthetic surface, you always want G2 continuity. Or G3, but I'm pretty sure G2 and G3 are essentially the same thing. You could read up in that in your own time. So with SolidWorks, it's not always possible to get the curvature to face or the G2 continuity. Sometimes it just simply won't let you do it. There'll be some failure or some underlying problem. Most of the time that's because you've done something wrong, but once a model starts getting complex and you've got a lot of surfaces, for example, if I wanted to make this surface G2 continuity to this and this, SolidWorks simply, it might not be possible. Whereas in CATIA or a more advanced modeling package designed specifically for surfacing, you would have a lot more functionality in that regard. So it would be easier to initially create the G2 continuity at all your surface boundaries, and then you would also be able to go back and update the form and shape of your model and to maintain that G2 continuity. So with G2 continuity, if every surface was perfect, we would see smooth transitions. Now, of course, some regions you don't want G2 continuity because the design actually has like a kink in it, like for example, like this kink running along the side or these kinks on the front hood. So you kind of have to do the best you can. So this region here it's an example where the continuity isn't ideal because we kind of just go from black straight to blue. And we can also see with the zebra stripes when there's like a sudden change. So it's not too bad here. But yeah, ideally we want the zebra stripes to be as continuous as possible. So what this means, if this model was actually fabricated in real life, it wouldn't be good enough to be an actual automobile because there would be visible kind of kinks and bumps all around the car. So yeah, that it's just it kind of comes down to SolidWorks not really being designed for surface modeling of such complex things. I think generally if you're like surface modeling like simple like products, like they can still have organic shape, but then they don't consist of too many surfaces. You can put the work in to make all the boundaries G2 continuous, but yeah, with something this big, it's not really practical. So moving on, created some more boundary surfaces. There I did a surface trim, I might just go back. So this is a very subtle feature here. This kind of edge of this surface I trimmed very slightly, probably just to get it to match the curvature of the blueprints a bit better. The surface trim tool is very similar to the split line and delete face features. Yeah, for the most part they're interchangeable. I did another surface which runs along the top of the windows. Jumping forward quite a bit. I believe here I started modeling the rear region of the car. Just did another surface trim there of the back of the car. So another point to make, when I'm modeling the back of the car, I might need to right click on the front blueprint and hide it, just so the back is more visible. Sometimes you might need to hide multiple things, like you might need to right click on a surface itself and hide it to get a better view of the specific area you're trying to model. So there I created a large surface and then did the surface trim to try trim it back. So again, iterating that point, if I'd just tried to model this surface in one go, it would have been difficult to get it as smooth as this. So it's a good example where it's ideal to use the surface trim tool. Okay, I just used the surface extrude tool somewhere. Let me find that. Okay, I just used the surface extrude on this line, which just extrudes a surface out in one direction from a three-dimensional curve or even a two-dimensional curve. And I then used the surface fill tool. The surface fill tool you can use when you've got surfaces bounding each side. And a split line again, and delete. Okay, surface loft. Let me find where I did that. Okay, this section here on the rear wheel, there's still part of the surface of the car we haven't done, so I just decided to use the Surface Loft tool. The Surface Loft tool is similar to boundary surface. I've found it's good when you have a long slither of a surface, but again, I'm pretty sure I could have used the boundary surface tool there and it would have been fine. To be honest, yeah, like a lot of these surfacing tools are kind of similar, and it's your choice which ones you want to use for whatever purposes you're doing. Here I use the Surface Extrude again, because just going back a step, I had this edge of where the wheel is sitting, and I just want to create like an internal socket for the wheel to sit in. So using the Surface Extrude, I can just specify the direction that I'm going to extrude out to create a surface. Did a similar thing for the rear wheel. Okay. So here I did a surface knit because these two sections were actually separate surfaces. And the reason I did that was so I could then do a surface offset using the Surface Offset tool. Now what that did was offset this whole surface by a set amount. So I put in 10 millimeters. And the reason I did that was so that I could then delete the initial face, and I kind of have that surface, like where the light would sit, the front light, I have it recessed in the car. So when I was modeling this, I did have the intention to 3D print it. So to kind of capture that detail once it's 3D printed, I thought a simple way to do it would to just be to recess these like front light sections, for example. I also did that with the windows later on, which I'll show you. And I might actually quickly just show you a final model that I 3D printed. So this is a small model I got SLA printed. Just try to get it to focus. So the detail came out pretty well. I'll just hide that one for a second. It's a bit dark, sorry, but yeah, the detail was reasonably good. And because this model's so small, you can't really see the discontinuities that I was talking about in the surfaces, just because they weren't too bad to begin with, and on a smaller model you're not going to notice them as much. But just before, how I was talking about the recesses, so if we look at that front light section, it's visible to us, likewise with the window sections, just because those surfaces were offset and then merged later on. And even some of the small detail, like the little T on the front of the Tesla, can't really get it to focus, but in real life you can see some of the small detail quite well. So yeah, I was essentially designing for 3D printing, which is why I made some of the decisions I did. But yeah, a real car would be more complex because you're designing it to, integrate with internal structures and mechanics. Moving forward, I did a model of the front window and top of the car and side windows. Here I did a surface offset of something on the rear. At this point, I used the split line feature again to split up the regions on the top, which are, the windows and actually still part of the metallic frame of the car. I used the surface plane tool to fill in these regions here. So actually just before that, what I did was I trimmed this surface using the surface trim tool to get a nice flat face, and then with that I can easily use the surface plane tool to just have a flat, fill in a flat plane in a section. Here I started using the surface extrude feature. Just wind that back. Okay, no, sorry, not there. Yep, there. So I used surface extrude to start pushing these regions back. And then the surface fill to fill in that area in there. Likewise, a surface fill on that section there. I wanted to fix up this front section here because I noticed on the picture it's not so flat, it's got some more kind of curvature to it. So I believe I trimmed away that section and then started rebuilding it with smaller surfaces, which you should be able to see. There's the first section, second, and third. So that was pretty small, but yeah, sometimes if you want to go back and add more detail to a section, you can just trim away a surface and rebuild it with smaller surfaces to capture some more detail. And finally I did the surface fill again to fill in that region. There I did the split line to split the window region into the actual glass and border sections, which we can see on the model here. There's kind of silver border sections. So at this point I wanted to create the recesses for the window. So this was actually quite tedious because I wanted to extrude the border sections out slightly, which I should be able to show you in a sec if I can just find it. So there we can see I initially had the one surface sitting flush, and then I did a surface offset and duplicated it about 10 millimeters off from the model. So we can see that that's not attached to the model at this point. And then from there I deleted the initial surface. And at this point I started using surface lofts to re-merge the section that I had just offset with the initial body. So this was quite tedious really because there were like a lot of sections. I had to go around the whole outside boundary and the whole inside regions. So yeah, it was a lot of features. I'm not sure if that's the most efficient way to kind of do that, but to be honest, I can't think of any other easier way to achieve that. I'm sure in other CAD modeling packages there are more efficient ways to do that, but yeah, in SolidWorks that was quite tedious to do. So yeah, at that point, yeah, you can see that I had these, it's not just like one flush surface, they're several offsets, but they're all merged back up. So just a quick note, initially when you're modeling this, it's all going to be grey, and then you go into, appearances and you add certain appearances later. It would be very difficult for me to go back now and remove all these appearances because I'm just rolling through the design history tree. So yeah, as soon as I roll over something, it's got the final appearance, whether it's like the red, the gloss red, or the silver, or the black that I made. But yeah, initially when you're modeling, everything's just going to be grey, and appearances is one of the final steps. So I'm just jumping over quite a few features here to skip towards some newer points. Yeah, I think actually at this point I wasn't happy with that region that I discussed earlier, which had poor surface continuity. So if I go back and turn on zebra stripes and curvature analysis, yeah, I wasn't really happy with this region. So I think yeah, I went back at some point and deleted that face, and I tried to use the surface fill command. So the surface fill command or feature, it sometimes is a bit more powerful than the boundary surface feature. But to be honest, yeah, well actually that did give slight improvement there. So yeah, you just got to play around with these things to really get the best results. So at this point, I'd essentially finished all the, intricate surfaces of the model, and I started knitting all the surfaces together, because if I just jump back a step, if I go up to surface bodies, we can see that it consists of 86 bodies at the moment. So to convert this surface model into a solid, we want to start knitting together the surfaces. So the way I did this was I took a modular approach, and I started off by knitting essentially all the red regions together, the exterior shell of the car, and turned on gap control to knit together any small gaps, and then that was all good. So then I moved on to knitting the rest of the car. So the second one was, the front window and all the recessed connections, rear window, side windows. And then I mirrored the whole body, the whole model around that side plane. So we can see it's slowly starting to come together now. Here I started adding some surfaces on the bottom of the car, nothing really too fancy here, just some surface planes and surface fill tools. Just waiting for it to load up. At the front and back there. And I finished the bottom. And then what I did at this point was I did a surface knit of the whole body of the car. So when this finishes loading, I'll just go into the options and show you. But if I go into this surface knit feature, there's an option, a checkbox which says create solid. So what that does is it essentially fills all the area enclosed by the surfaces with material. So if I just roll back a step, if I do a section view and run through the model, we can see at this point it's still a hollow shell. It's a bit hard. What I might do now is just turn off the blueprints to make it a bit easier to see everything. At this point, it's still a hollow shell. So I wanted to 3D print this, and yeah, it's impossible to print a shell with 0 thickness, like there, for example. So doing that surface knit and checking the create solid option fills it with material, so it's now a solid body. Jumping forward, for some reason the model lost the information about the surface splits I'd done before, so I just redid them. Okay, at this point I started modeling the side view mirrors, which were a little bit tricky, but nothing impossible. So essentially I had the blueprints turned back on, and I started creating 3D sketches which followed outlines on the blueprints, and then using surface tools to fill in surfaces in those regions. So I mentioned at one point that SolidWorks prefers to have a 4-sided surface, like a surface with 4 boundary edges. but I have found that with the surface fill tool, it's actually fine to create a three-sided surface. So I think this is the only proper way you can create a three-sided surface in SolidWorks, is to use the surface fill tool. I know, like, you can get away with it with other tools, like it will work and it will build it, but there will be underlying mathematical errors which will sneak up in weird and interesting ways later on. But yeah, if you're interested in that, just, you know, research it a bit more. I started creating some surfaces to connect it to the body of the car. So I'll actually hide this surface on the car. Okay, I can't do that because the car's a whole model. Maybe I can. Okay. Do a section view. So we can see here that I'm connecting up this inner void to the car body. But I'm actually struggling to get a good view to discuss what I want. So just bear with me for a second. Okay, so at that point before, I tried to merge. I created a solid body out of the side view mirror and tried to merge it with the car body. But SolidWorks was failing, it wouldn't let me do it, and that's just an error when there might be like real minuscule gaps between your two bodies. So what I found I had to do was do a surface extend. So I'll hide the body of the car here. I did a surface extend. So essentially making it so this side view mirror is intersecting with the car body, not just touching it. And then once I'd done that, it let me merge the two bodies together. Or combine them, I should say. It combines the feature to use in that case. So at this point, I'd finished all the surfacing. The remaining features are solid features. Just things like Boss Extrude to create the front Tesla logo. And yeah, cut extrude somewhere, and then some split lines to create the logo on the back, and I think some more to create the door handles. So because these split lines are just on, you know, flush surfaces, when I 3D printed them, they didn't actually show up because there's nothing to see. So on this model, there's actually no like door handles that are visible. Had I wanted to make them visible, I would have had to either recess them in or out, and I couldn't really be bothered at that stage. I'd achieved what I wanted to. So the next step was creating the wheels, so I'll just minimize that for a second. And the wheels actually weren't too difficult to make, they were fairly easy, so I'll just quickly run through that. So like we had earlier, you want to have your blueprints because that's essentially how you're going to get the shape and form of the wheels. I did an extrusion, a cylindrical extrusion, just to create the, you know, outer tire section. Some fillets to make it a bit smoother, pretty standard stuff. And I started creating some planes. And I did a revolve, so I'll just show you the sketch for that. So that sketch there, I revolved it around the circumference to create that shape. I'm sure I could have done that a different way. I could have done a fillet. Oh, actually, I wanted some curvature. I wanted that to be slightly curved, which is why I did a revolve instead of a chamfer, for example. I did a boss extrude for the central hub. And then this was really the only tricky part. I created some angled planes, and I used this to create the spokes of the wheel. And then I did a loft. So I go into this sketch. Now here I went to the spline options, and I did spline on surface. And I drew my splines on that surface there, the revolved surface. Likewise, I drew a spline on this surface here. And then I did a 3D sketch to draw some guide curves between them. And then I just did the loft feature. So the loft, you select your two profiles and then your guide curves. And that was actually a solid loft, so it wasn't surfaces that I had to knit and make a solid later on. Then I just did a circular pattern of that. So yeah, I patterned that 10 times. And some fillets to make it a bit smoother, and that was it. So yeah, those wheels aren't like exactly accurate, but yeah, it was good enough. Like, you're never gonna 100% mimic the original design. So that was essentially it. That's like a high-level overview of how I made this Tesla Model S model. Like I said, it took me about 50 hours to do this, but that was over a period of 3 months. I just turn on the real view. So I turn off the perspective view, which it's good to have off while you're actually modeling, just to get your proportions right. It's a good idea, but yeah, it looks a bit better when you turn it back on. And then the real view graphics gives it a nice touch in the end. So yeah, it was a learning process for me, and doing this was actually interesting because I discovered the limitations of SolidWorks. Really getting, it's difficult, if not impossible, to maintain G2 surface continuity at all nooks and crannies on like such a complex model, and it's even more difficult to go back and update the form of your model. So in the automotive industry, I'm pretty sure CAD is the standard package. I'm pretty sure aeronautical industry and automotive industry do use CAD. Like, I think Tesla actually would have used CAD to model the Model S. I've never actually used it. I would like to, but it's a very expensive package. And yeah, I did some renders. I'll quickly show you. It's one render I did. I didn't particularly master the renders. To be honest, I don't find SolidWorks rendering package to be too amazing. It's decent, but I think there are definitely better ones out there. Like for example, the wheels look pretty good here, but then the front bonnet section of the car doesn't look too realistic. Yeah, that one's kind of similar. But yeah, I'm sure I can go back and learn some more things about the rendering. So if you like this video, give it a thumbs up, and if there's any more details you'd like to know, comment below, and I hope this helped and you've learned something and found it interesting. Alright, thank you.